What do your favorite pair of jeans, a luxurious Persian rug, and a humble cotton t-shirt have in common? They all owe their existence to one incredible, age-old machine, the loom. If you've ever marveled at the intricate patterns on a medieval tapestry, or felt the soft embrace of a freshly woven blanket, you've felt the work of a loom. But what exactly is a loom? And how did a wooden frame with some strings change the world so dramatically that it helped spark the Industrial Revolution? Grab a cup of tea, settle in, and let's travel back in time. Plus a few jokes, because the story of the loom is part history, part engineering, and part how many weavers does it take to change a light bulb? The simple act of weaving. Long before anyone coined the term loom, humans were already weaving. Think of the earliest hunters sitting around a fire, twisting plant fibers together to make cords, nets, and baskets. That basic over-under technique, taking one strand and passing it over, then under the next, is the DNA of every fabric you've ever worn. When our ancestors realized they could create a more stable structure by crossing two sets of threads at right angles, they invented the warp and the weft. The warp is the tight, lengthwise threads that stay stretched on the loom. The weft is the thread that zigzags back and forth, interlacing with the warp. It sounds simple, but that simple crossing is what turned a tangled mess of fibers into cloth, sails, and even the first smart textiles, if you consider a loincloth smart. By about 5,000 years ago, the ancient Egyptians were using a basic loom, a couple of wooden beams, some heddles, the little devices that separate the warp threads, and a shuttle to carry the weft. These early looms were handheld or ground-based, and the process was painstakingly slow. Now picture a busy ancient market, a weaver hunched over a loom, eyes narrowed, hands moving faster than a caffeinated squirrel. Every few seconds they'd have to stop, pull the weft, beat it into place, and then start again. It was a rhythm, a meditation, and a full-body workout all rolled into one. But as societies grew, the demand for cloth exploded. Farmers needed more sails for ships, armies needed more banners, everyday folks wanted more than one tunic, and that demand set the stage for the loom's big upgrade. Defining the loom. So, what exactly is a loom? In its most basic form, a loom is any device that holds a set of warp threads under tension and provides a way to interlace the weft thread. Traditional looms consist of a frame, a warp beam, the roll that holds the lengthwise threads, a cloth beam where the finished fabric rolls up, heddles, and a shuttle. The heddles, often made of string, wire, or metal, lift or lower the warp threads in a precise order, creating an open shed that the shuttle can pass through. The shuttle, usually a small boat-shaped piece of wood or metal, carries the weft thread across the shed in one smooth motion. When the shuttle returns, the weaver beats the weft tight against the previous row with a reed or beater, compressing the fabric. Every time the shuttle goes back and forth, a new line of fabric is added. It's a beautifully simple cycle. Lift, pass, beat, repeat. But the true power of the loom isn't just in its simplicity. It's in the way it can be mechanized, scaled, and, eventually, turned into a machine that could outproduce 100 skilled hands. Hey, if you're enjoying this journey through the world of weaving, don't forget to hit that like button and subscribe to the What Is channel. We've got plenty more stories where this came from, each one exploring the fascinating origins of the things we use every day. Let's get back to the story of the loom. The first mechanical leaps. The earliest mechanical enhancements were modest but revolutionary. The warp-weighted loom, used by the Greeks and Romans, suspended heavy stones or clay weights from the warp threads. These weights kept the warp taut, allowing the weaver to create a wider fabric without the whole thing collapsing. Fast forward to medieval Europe, and you see the drawloom. The drawloom added a mechanism that could lift groups of warp threads automatically, creating complex patterns like damasks and brocades. Picture a medieval guild hall, dozens of drawlooms clicking away, each one staffed by a master weaver who could literally program patterns by pulling a series of cords. The complexity was astonishing. Some fabrics had hundreds of heddles, each controlled by a separate cord. It was the textile industry's first software. Each pattern was a new program run on the same hardware. Legend has it that an apprentice once asked his master, "How do you remember which cord to pull?" The master replied, "Young man, I've been weaving for 40 years. My fingers know the pattern better than my brain does." And that's the secret of early weavers. Muscle memory was the original AI. But even with these clever devices, the process remained labor-intensive. A skilled weaver could produce perhaps a yard of fabric a day, far below the burgeoning demand of an expanding world. The Industrial Revolution enters the loom. Enter the 18th century industrial boom, and everything changed. The first major breakthrough was John Kay's flying shuttle, patent 1733. Kay's invention used a mechanical boat that could be thrown across the warp at high speed, eliminating the need for the weaver to reach across the fabric. Think of it as the original hands-free device. Imagine a weaver sipping tea while the shuttle darts back and forth. Well, not sipping tea, but you get the idea. The flying shuttle boosted productivity by roughly 25% and allowed a single weaver to produce wider cloth. But the real big gun of the textile revolution was the power loom. In 1785, Edmund Cartwright patented the first practical power loom. It used water and later steam to drive the mechanisms that lifted the heddles, moved the shuttle, and beat the weft. The power loom could turn out many yards of fabric per hour, far outpacing any hand loom. Here's a fun fact. When the first power looms were installed in factories, some traditional weavers reportedly stood outside, watching the machines with a mix of awe and suspicion. One old weaver is said to have muttered, "Those machines will never replace the feel of real cloth." He was half right. They didn't replace the feel, but they certainly replaced the job. The power loom sparked a cascade of social changes. Factories sprang up across England, then Europe, then America. Entire villages that once thrummed with the rhythmic clack of hand looms became mill towns, where the clang of iron and the hiss of steam became the new soundtrack. The textile industry became the engine of the Industrial Revolution, fueling everything from railway construction to the rise of global trade. The human cost and the Luddite rebellion. Of course, progress is rarely a smooth ride. As power looms took over, hand loom weavers saw their livelihoods vanishing. Wages plummeted, and many families who had depended on weaving for generations found themselves in poverty. Enter the Luddites, not the sci-fi bots, but a group of English textile workers who, in the early 1800s, smashed the new machines in a desperate bid to protect their jobs. They named themselves after Ned Ludd, a folklore figure who supposedly destroyed a knitting frame as a child. The movement turned violent at times, factories were burned, and troops were sent in. It's a poignant reminder that every technological revolution has a human side. Fast forward a few decades, and the world adapted. New jobs emerged: machine operators, maintenance technicians, textile designers, and later, marketing and sales. The loom had become a symbol of both progress and displacement, a story that echoes across every wave of automation we see today. But the loom's influence kept expanding. From steam to silicon. By the late 19th century, the loom had gone electric. Electric motors replaced water wheels, making factories more flexible in location. The 20th century brought the shuttle-less loom, also known as the projectile loom, or rapier loom. Instead of a wooden boat shuttling back and forth, these machines use small projectiles or gripping arms to carry the weft thread across the warp at astonishing speeds. Modern high-speed looms can produce up to 2,000 meters of fabric per hour, an amount that would have taken a hand weaver centuries to match. And today, the latest generation of looms is fully computer-controlled. Designers can upload digital patterns directly to the loom, which automatically selects the correct heddle lifts, adjusts tension, and weaves the fabric to exact specifications. The digital loom is essentially a 3D printer for textiles, capable of creating complex patterns, hybrid materials, and even functional fabrics embedded with sensors. Imagine a jacket that can monitor your heart rate, or a curtain that can change color with the flick of a switch. That's not science fiction, it's the modern loom at work. The loom's legacy in everyday life. So why should you care about the loom when you're scrolling through your phone or picking out a new outfit? Because the loom is the invisible thread linking ancient craftsmanship to the fabrics we rely on today. The denim in your jeans, woven on a loom, the cotton in your t-shirt, woven on a loom, the satin of your favorite pillowcase, woven on a loom, the technology that started with a couple of wooden beams and some string has morphed into a multi-billion-dollar global industry that touches every aspect of human life, from fashion to aerospace, medicine to sports. And the loom story doesn't end. Researchers are now exploring biolooms that can weave living cells into tissue scaffolds, smart textiles that can store energy, and even recyclable looms that turn old garments back into new threads. The loom is still evolving, still weaving the future. Let's quickly tie it all together. A loom is a device that holds warp threads under tension and interlaces weft threads to create fabric. From ancient hand loom roots to the medieval drawloom, the loom steadily grew more sophisticated. The flying shuttle, power loom, and later the electric and shuttle-less looms transformed textile production. These inventions powered the Industrial Revolution, shifted economies, and even sparked social movements like the Luddites. Today, computer-controlled looms are pushing the boundaries of what fabric can be, function, fashion, and beyond. The next time you pull on a shirt or unfurl a blanket, take a moment to appreciate the centuries-old ingenuity that made it possible. Thanks for watching. If this story sparked your curiosity, please subscribe to What Is and hit the notification bell so you never miss a new episode. Drop a comment below. What other everyday marvels would you like us to unwrap? Until next time, keep weaving, keep wondering, and keep asking. What is? See you next time.